In this example, I'm going to show you how to find the function that's continuous. The function is continuous, meaning it has no hole or jumping in the graph. But if you have no graph to determine if this function is continuous or not, first thing, we have to find what is f at 3, because I want to know what is my function continuous at 3 or not. So I want to know is there output when x is 3. So when x is 3, I have 9 minus 5 equal to 4. And part B, I have to find the limit of the function when x go to 3. So that means we have to find the limit of the function go to the left or to the right. But however, you see that 3 is inside the domain of my function. So therefore, to find the limit of this function, all we have to do is put 3 inside here. I have 9 minus 4 minus 5 is 4. And part C, seeing the output of the function, it is same thing as the input of the function. Since the output of the function is the same thing as the limit. Therefore, I have f of 3 is the same as the limit of the function. So my conclusion is yes, this function continues as 3. I'm going to show you another example. See, it help you to understand this. I want to see if this function g here is continuous at a point minus 2. And first we have to test. Okay, is there output as minus 2? So let's see. I want to evaluate g at minus 2. So minus 2, it belongs inside this domain because this domain say that x is greater or equal to minus 2. So therefore, I'm using this equation here to evaluate g value, which is equal to minus 2 minus 1. I put minus 2 inside here. I have minus 3. Now we need to find the limits. The next question is our function exist when x go to very close to minus 2? So first, I'm looking for the limit of g when x go to minus 2 to the left. Okay, because that's how we find a limit, looking to the left and to the right. Versus part A, because I see that 3 belongs inside my domain here, so it's easy for me to include it equal to 4. In this case here, I have to do a little longer way. So when x goes very, very close to minus 2, here's minus 2, and go very close to minus 2 on the left. So right here is minus 3, right here is 0. So I'll go very close to minus 2, like minus 2.001, which is, see, is it less than or greater than minus 2? Minus 2.00001 is actually less than minus 2. So therefore, I'm using this domain. So I have my 1/2 times minus 2. Because when you go very, very close to minus 2 to left, right here is like minus 2.001. So I can say to round off of minus 2 instead. Plus 3. 1/2 times minus 2 is minus 1. Plus 3 is 2. Then now we find a limit of this function when x go to 2 on the positive side, to the right side. So right here, I'm approaching minus 2 to the right. When you go very close to right here, approximately about minus 0.111, about minus 1.99, excuse me. So you go this way, it's be but almost 2, so minus 1.99999. minus 1.9999 is actually greater than minus 2. So I'm using this domain. So I put the value inside here, but now minus 1.999 is almost like 2. So I put a 2 inside here. Then minus 1 equal to minus 3. You see, the limit from the left is not the same as the limit from the right. Therefore, the overall limit does not exist. So that means because the limit of G over R doesn't exist. So therefore, this portion here is not equal to each other. So therefore, the answer is no. My function is not continuous as minus 2. That's it. So overall, all you have to do is check to see if the function is there output of the function. Is there a limit? If there is this limit here is the same as the output. If they're the same, therefore the function is continuous at a point. In this case, the answer is no. For A, I see that the output is the same as the limit, therefore the function is continuous at 3.